Hello everyone. And welcome back once again to another interesting video. In this video we'll discuss most important commonly asked Java interview questions and answers for beginners and experience. So if you are ready, let's start today's video. Question 1. What are shallow copy and deep copy in Java? Answer. In Java, shallow copy and deep copy are mechanisms used to duplicate objects. However, they differ in how they handle object references within the copied object. Let's discuss one by one. 1. Shallow copy. Shallow copying creates a new object and then copies the non-static fields of the current object to the new object. However, if the field itself is a reference to an object, only the reference is copied, not the referred object itself. In other words, a shallow copy creates a new object but doesn't create copies of nested objects. Instead, it copies references to the nested objects. So, both the original object and the copied object will share the same nested objects. Shallow copying in Java can be done using the clone method, by implementing the clonable interface, or by manually copying each field. Shallow copying is a relatively simple and fast operation. 2. Deep copy. Deep copying creates a new object and then recursively copies all fields of the original object, including any nested objects. This means that the copied object is entirely independent of the original object, with no shared references to any nested objects. Deep copying ensures that changes made to the copied object do not affect the original object, and vice versa. Deep copying in Java often requires custom implementations, as it's not directly supported by the language itself. One common approach is to implement a deep copy method that traverses the object graph and creates new instances of all referenced objects. Deep copying can be more complex and computationally expensive compared to shallow copying, especially for objects with complex nested structures. Here's a simple illustration of shallow copy versus deep copy. In this example, a shallow copy of original person would result in copied person sharing the same address object as original person. However, a deep copy would ensure that copied person gets its own separate address object. Question 2. Apart from the security aspect, what are the reasons behind making strings immutable in Java? Answer. Immutable strings in Java offer several benefits beyond just security considerations. 1. Thread safety. Since strings are immutable, they cannot be modified once created. This property makes them inherently thread-safe, meaning multiple threads can safely access and share string objects without the risk of data corruption or unexpected behavior due to concurrent modifications. 2. Caching and performance optimization. Java's string pool, which stores unique string literals in memory, can leverage the immutability of strings for caching purposes. Since strings are immutable, the JVM can safely reuse existing string instances rather than creating new ones when the same string value is needed elsewhere in the code. This can significantly reduce memory usage and improve performance by avoiding unnecessary object creation and garbage collection overhead. 3. Hashing and security. Immutable strings facilitate efficient and secure hashing mechanisms, such as those used in hash tables, cryptographic algorithms, and data structures like Java's hash set and hash map. Immutable strings ensure that the hash code of a string remains consistent throughout its lifetime, preventing potential security vulnerabilities and ensuring the integrity of data structures that rely on hashing. 4. Simplified memory management. Immutability simplifies memory management and reduces the risk of memory leaks and unintended side effects. Since strings cannot be modified after creation, there is no need to defensively copy or clone string objects to prevent unauthorized changes, leading to cleaner and more predictable code. 5. Simplified multithreading and concurrency. Immutable strings eliminate the need for synchronization or locking mechanisms when dealing with shared string objects in concurrent or multi-threaded environments. Developers can safely pass string references between threads without worrying about concurrent modifications or race conditions. 6. Design clarity and predictability. Immutable strings promote clearer and more predictable code by enforcing a set-once semantics, where the value of a string remains constant throughout its lifetime. This design choice simplifies reasoning about program behavior, enhances code readability, and reduces the likelihood of bugs related to unintended modifications or side effects. Overall, the immutability of strings in Java offers numerous benefits beyond security, including enhanced performance, thread safety, memory efficiency, and code clarity, making it a fundamental aspect of the language's design and programming paradigm. Question 3. What is a singleton class in Java? And how to implement a singleton class? Answer. In Java, a singleton class is a design pattern that restricts the instantiation of a class to a single instance, ensuring that only one instance of the class exists in the entire application. The singleton pattern is commonly used when exactly one object is needed to coordinate actions across the system, such as a database connection pool, logging service, configuration manager, or thread pool. To implement a singleton class in Java, you typically follow these steps. 1. Private constructor. Make the class constructor private to prevent direct instantiation from outside the class. 2. Static method for instance retrieval. Provide a static method that acts as a factory for obtaining the singleton instance. This method creates the instance if it doesn't exist or returns the existing instance otherwise. 3. Private static instance variable. Declare a private static variable to hold the single instance of the class. 4. Lazy initialization, optional. Implement lazy initialization if you want to defer the creation of the singleton instance until it is first accessed. 5. Thread safety, optional. Implement thread-safe mechanisms if your singleton class will be used in a multi-threaded environment to prevent race conditions and ensure that only one instance is created. Here's an example of a basic singleton class implementation in Java. In this example, the constructor is private to prevent direct instantiation. The getInstance method provides a static way to access the singleton instance. It uses lazy initialization to create the instance only when it's first accessed. The instance variable holds the single instance of the class. It's declared as private static to ensure that it's accessible only within the class and shared across all instances. This implementation ensures that only one instance of the singleton class is created, even in a multi-threaded environment, and provides a global point of access to that instance. Question 4. What is a comparator in Java? Answer. In Java, a comparator is an interface defined in the java.util package that allows custom sorting of objects. It provides a way to define a comparison logic separate from the class whose objects are being sorted. This is particularly useful when you need to sort objects based on criteria other than their natural ordering, for example, the ordering defined by the comparable interface. The comparator interface contains a single method. Here, O1 and O2 are the two objects to be compared. The compare method returns a negative integer, 0, or a positive integer depending on whether the first object should be placed before, at the same position, or after the second object in the sorted order, respectively. In addition to the compare method, the comparator interface also provides several default and static methods for composing comparators, reversing comparators, and creating compound comparators. Using a comparator allows you to sort objects in various ways without modifying the original class or its comparable implementation. It's commonly used when you need to sort objects based on different criteria at different times, or when you don't have control over the implementation of the class being sorted. Here's a simple example demonstrating how to use a comparator to sort a list of objects. In this example, we define a person class with name and age attributes. We then create a comparator named byAge that compares person objects based on their age attribute. Finally, We sort a list of person objects using this comparator, resulting in the list being sorted by age. Question 5. What are the differences between HashMap and HashTable in Java? Answer. HashMap and HashTable are both implementations of the map interface in Java, but they have several differences. 1. Thread safety. HashTable is thread-safe, meaning it is synchronized, while HashMap is not. This means that HashTable can be safely used in a multi-threaded environment without external synchronization, whereas with HashMap, external synchronization is required if it's accessed by multiple threads concurrently. Because HashTable is synchronized, it's typically slower than HashMap, which can be a consideration in performance-critical applications. 2. Null keys and values. HashMap allows null keys and null values, meaning you can store key-value pairs where either the key or the value, or both, is null. HashTable, however, does not allow null keys or null values. Attempting to store a null key or value in a HashTable will result in a null pointer exception. 3. Iterators. Both HashMap and HashTable support fail-fast iterators, which means that if the underlying map is modified structurally, for example, elements are added or removed, after an iterator is created, the iterator will throw a concurrent modification exception. However, iterators for HashTable are not fail-fast by design. Instead, they rely on synchronization to prevent concurrent modifications. 4. Performance. HashMap typically offers better performance than HashTable due to its lack of synchronization. In single-threaded applications or situations where thread safety is not a concern, HashMap is generally preferred for its higher performance. Additionally, because HashMap allows null keys and values, it may offer more flexibility in certain use cases. 5. Legacy. HashTable is a legacy class that has been present since the earliest versions of Java and is part of the original Java Collections framework. HashMap, on the other hand, was introduced later and provides a more flexible alternative to HashTable. While HashTable is still supported for backward compatibility, HashMap is the preferred choice for most new applications. In summary, the key differences between HashMap and HashTable lie in their thread safety, handling of null keys and values, performance characteristics, and legacy status. In most cases, HashMap is preferred unless thread safety or compatibility with legacy code is a primary concern. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.